derivative number line. And we're going to plug in, what are we plugging in? We're plugging in -3 and we're plugging 1. And remember, we're plugging into the derivative because we're trying to solve where is the derivative greater than 0, where is the derivative less than 0. So we're going to plug into the derivative right before we set each factor equal to 0. That is the most simplified version of our derivative. Okay, so again, I kind of mentioned that back over here right before I set those guys equal. That's the formulation of the derivative that I want to plug into. So right before I set them equal to 0, those factors equal to 0, that's what we're going to plug back into. Okay, and then we create our little chart. And again, we are doing this without a calculator. All right, so there is no need to punch a button here. And what's going to happen is we have 3 intervals. So we are going to test this first interval. And we can plug in any number we want to plug in as long as it's inside of that interval. So it's kind of random what you pick. So I might pick -5, someone else might pick -10. Just as long as it's inside that interval, you're good to go. So I'm going to plug -5. e to the -5, -5 plus 3, -5 minus 1. Now again, you do not need a calculator for this question because people sometimes stress out about this e to the -5, but remember what you do with negative exponents. What do we always do with negative exponents? We move them down. So e to the -5 is going to be 1 over e to the 5th. And when you see that, hopefully you're like, oh yeah, that's a positive value. Another way of approaching this, remember what we said on the previous page, e to the x is always greater than 0. So it doesn't matter if you have a negative exponent, if it's a positive exponent, it's always greater than 0. So this first factor is going to give you a positive. The second factor, -5 plus 3, gives us a negative, and then the third factor gives us a negative. So those two negatives will give us a positive. Then we take a positive times a positive, so we get a positive overall. Okay, so for my first interval, I am looking at a positive. So then I go to my second interval, and again, all of this work should be shown on your test. It should not be that on your test you magically get the number line and you didn't have to lift a pencil. Like it should be, okay, here's my plugging in, kind of showing me the work that you did there. All right, so for this middle interval, maybe I decide to plug in 0. So I have e to the 0, 0 plus 3, 0 minus 1. And again, e to anything is going to be positive, positive, and a negative. So that's going to throw us into a negative. Okay, now we should make a mention here of what those negatives mean to us and what that positive means to us. So remember, when the derivative is positive, that is telling us that we are going up the hill. And when the derivative is negative, that's telling us that we're going down the hill. All right, then from 1 to infinity, we need to plug in some numbers. So let's say I plug in 2. So I have f prime of 2. That gives us e squared, 2 plus 3, 2 minus 1. So that's going to give us a positive, positive, positive. So we get a positive. So that positive again would indicate to us that we are increasing, that we're going up the hill.